Okay, so I focused on the field of industrial hygiene, and my topic was evaluating two tools used to predict workplace chemical exposures. So a bit of background information on the field. So typically there's going to be some chemical exposures in workplaces that might result in bodily harm to workers. And as a result, organizations such as OSHA, um, come together to develop regulations concerning these tasks. And basically, if these regulations, regulatory limits are exceeded, then current practices can't continue until certain steps are taken, whether it be further worker training or things like increased engineering controls, which might take the place of improved ventilation systems. So behind all these tasks are the industrial hygienist. Basically, the industrial hygienist conducts exposure assessments to determine whether or not a workplace exceeds these regulatory limits and provides advice concerning what further steps should be taken. And to do this, he or she typically sorts these exposures into something called exposure control categories. So we have ranges of exposure levels related to how serious the danger is, from 1 to 9, 1 being the least dangerous and 9 being the most dangerous. We take the 95th percentile exposure to capture 95% of the potential exposures, and a bit about how this is calculated. Essentially, these ranges, these categories are directly correlated to the ratio between the actual concentration of the contaminant and the regulatory limit. So for example, if we have a 1-to-1 ratio between the contaminant concentration and the limit, that's going to be a category 3 exposure. So the industrial hygienist has to deal with a lot of different things in the workplace, since every workplace is different. And as a result, they typically use some tools to help them. Benefits are that they're objective and structured, and they focus the hygienist on the most critical variables, so that they won't be distracted by unnecessary stimuli that will get in the way of their decision making. And perhaps most importantly, they're relatively low cost due to the fact that there's not really a need for sampling. So we take information directly from the workplace and input them into these tools, but we don't actually take physical measurements. So that eliminates a lot of the time cost and monetary cost. So a couple different types of tools. First category of tools is mathematical modeling. These are probabilistic tools that take some inputs, and basically they generate a confidence interval of likely contaminant concentrations within the workplace. And since we're generating a confidence interval of likely exposures rather than one set output, the main advantage of this is that it captures the variability of real world situations. Since given a particular workplace, we're not going to have the same concentration in different areas of the room or on different days of the week, and so on. And lastly, they're customizable. There's one type of mathematical model called a near field far field model, where essentially the worker's immediate breathing zone is described as the near field, and it's going to have a much higher concentration than the far field, which is going to be the outer corners of the room. So there's different types of models that are designed to be customized to different designs and different types of rooms. So this can increase the accuracy of these tools. Secondly, there are checklists. These guide the application of several chemical principles. Typically, these can be rather difficult for industrial hygienists to apply accurately, but one example of a checklist uses a spreadsheet that essentially combines several of these principles and makes it easy for the industrial hygienist to simply input a few simple variables, and then the spreadsheet will take care of the work for him or her. So main advantage of these checklists is that they are going to be very efficient. So the gap, how does the more well-established method of mathematical modeling compare to the newer checklist? So mathematical modeling, there's quite a bit of literature supporting their efficacy. They're known to be pretty accurate, but checklists, since the developers of the checklist kind of sacrificed a little bit of the accuracy for speed, they're a lot more efficient. We have yet to see whether or not they can provide an extremely accurate exposure assessment. So this brings us to my research question, which is using checklists or mathematical modeling more effective for conducting accurate and precise exposure estimates on different chemicals that may be hazardous in workplace environments? So in my study, for my mathematical model, I used the IHMOD 2.0. As you can see, there's quite a bit of scenario-specific information, different measurements from this particular scenario, such as the emission rate, which is how fast the chemical is generated, and we can see our confidence intervals here. And for the checklist, I used the SDM 2.0. As you can see, there's less scenario-specific information that's required than the mathematical model, so a simpler design overall. So my methodology, I compiled case studies from a variety of industrial processes, all the way from exposure to acetone in a nail salon to the cleaning of semiconductor wafers in a more industrial setting. The SDM outputs the exposure control category directly, while the IHMOD actually outputs concentration in parts per million. So I actually had to standardize it into exposure control categories in order to allow for easier comparison. And lastly, I charted my results, the results from these tools side by side. And I did this because Dr. Arnold, who's here today, she actually conducted a similar study in which she used a similar design for the chart. So I believe that this was the most efficient way to easily see the overall trend. So here we can see that along the x-axis we have the departure from the actual estimate. So for example, this blue point on the far right here, this means that the predicted exposure from the tool was 3 plus 3 categories above the actual exposure. So yeah, that's the chart, and some immediate observations I made. Firstly was the relative spread of the SDM in the blue here. We can see that it's much more spread out than the other two. And this was due to the fact that, as previously mentioned, there was less scenario-specific information. So it's naturally going to be less precise. In addition, I noticed an overestimation bias. As we can see with the SDM, for 5 out of the 10 scenarios, we had an overestimate of 1 or more exposure control categories. And digging deeper into why this was the case, I found that the developers of this tool actually calibrated it to provide a slight overestimate in order to minimize the number of times we would receive an underestimate, since an underestimate is going to be have far more severe consequences than an overestimate with regard to worker safety. Additionally, there's a couple of the scenarios I looked at were chemical mixtures, since one of the newer features of the SDM tool was that it was supposed to be able to evaluate chemical mixtures instead of like pure chemicals. But unfortunately, this went 0 for 2 as far as predicting the correct exposure control category. In fact, both of these +3s right here are from the chemical mixtures. So that might be an area in which further research is needed to see how the SDM might be recalibrated to effectively estimate exposures from chemical mixtures. Looking at the overall strength, however, we see that it's generally pretty strong. So a typical criteria used within the industry is the idea of being within 1 exposure control category. And when we look at my results from through this lens, we see that we've achieved pretty high accuracy. For the SDM, we see that there were only 2 scenarios, 2 out of the 10 scenarios where it was outside of this range. And the IHMOD, both the well-mixed room model is a different model, but for both of the models within this tool, we see even greater accuracy. For the near field, far field model, we see that for all 10 of the scenarios, we were within 1 exposure control category. And for the well-mixed room model, we had 9 out of 10 in that range. But looking a little deeper into the cases where the SDM was inaccurate, we arrive at the engineering controls, which I described earlier as essentially an estimate of what steps have already been taken with regard to controlling the amount of airflow within the room. And we see here that this is a screenshot from the SDM tool, and we can see that based on which selection we made from very limited to containment, we have a very wide range of eventual outputs. So we might expect that there's a lot of guidance on arriving at this extremely important input. Since we see here that it has a disproportionate influence on our final assessment, but looking at the guidance on it, we found that it was largely subjective. It ended up being up many times up to the industrial hygienist's own personal experiences. So I concluded that further guidance has to be needed. Further guidance is needed in helping hygienists arrive at the correct level of engineering control, since it had such a large influence on our final result. So conclusion. So despite varying precision, I found that these tools were largely accurate. Using the criteria of plus or minus one exposure control category, even the less accurate tool, the SDM, was within that for 8 out of the 10 scenarios. And the study also supports existing literature on mathematical modeling. So a study conducted by Mark Nikas from UC Berkeley School of Public Health provided a lot of support for the use of mathematical modeling, and my result essentially agreed with that, since not only did we see a lot of categorical accuracy, but looking at the exact outputs in parts per million, there was extremely strong agreement. And in addition, there was new checklist evidence for non-mixture solutions. Despite the fact that we saw a rather large spread, overall, we were pretty accurate in predicting the correct exposure control category for non-mixture solutions. Since for both of the mixture solutions that we evaluated, we were off by 3 categories. So that might need to be looked at more, but overall, we received pretty strong results. And lastly, we have the question of precision versus accuracy. So the trade-off that was made in developing the SDM was a little bit of precision, and the mathematical modeling tool was much more precise. However, we saw that both of these tools were very accurate in terms of categorical accuracy. So as far as implications for the field, both of these tools, there's strong evidence that they can be used to effectively assess workplace exposures. However, depending on what you're looking for, the IH mod or mathematical models might be recommended if we're looking for extremely precise concentration estimates, while both of them will do the job for pure accuracy. Lastly, I'd like to thank Mrs. Swenson, who's not here today, and Mrs. Layden, my HMC teachers, for all the guidance they've provided as far as teaching me how to conduct a research project throughout this whole year. And I'd also like to thank Dr. Arnold, who's here today. She's an assistant professor of environmental health sciences at the University of Minnesota and was my mentor throughout this process, and gave me a great deal of guidance developing background on the field and making my way through my research project.
Nice job, Richard. I have some questions for you. As you know, there are oral defense questions that you've had an opportunity to see in advance, and I will be asking you one question from each category: the research process, your depth of understanding, and reflection on the inquiry process. And my first question for you is, how did you handle uncertainty in the research process?
Yeah, so the thing that immediately comes to mind was when I was using the IHMod tool for a couple scenarios, I got a concentration that was like 10 times what I was supposed to get. And that was definitely a little surprising and a little like I was a little panicked at first, but I mean that was introduced a lot of uncertainty into my project since my results appear to be completely off. But I tried to take it in stride and look back on my work, and I found out that for some of the scenarios, the model typically assumes that there's a constant level of exposure throughout a worker's entire shift. But what I found with some of the scenarios was that there were periods of time where the worker wasn't in direct contact with the chemical contaminant. So I had to do a little bit more math to figure out what percentage of that exposure was should have actually been counted. Yeah, so that was a big piece of uncertainty that I encountered in February, I think. But I persevered and looked back through my work to find any missing details in order to overcome that issue.
As a follow-up to that, I'm just curious for that unexpected result that was so high, as you did apply some math to figure out the actual exposure, did you find a different result? Did it come more in line with what you would have expected?
Yeah, yeah. That the actual result I got was much lower and seemed much less likely to cause immediate danger to workers.
Interesting. All right, my next question for you is for you to tell me a little bit more. You've alluded to this, so you've already answered it to some degree, but tell me about the limitations of your method and how it influenced your new understanding.
Yeah. Um, so with I guess one limitation I saw was with regard to the chemical mixtures. One goal of my project was to um, see how effective the SDM tool was at evaluating chemical mixtures. But I did only end up using two of those scenarios in my study. So even though um, one of my conclusions was that the SDM wasn't too accurate at evaluating chemical mixtures, I guess a limitation would that be that with only two case studies, it was a little difficult to see that completely. So I guess for future studies, it might be good to evaluate the SDM with more case studies in that category.
Excellent. And then my last question for you is, how did the choices that you made when designing your research method impact your actual research process itself?
Sorry, can you repeat that?
No problem. My question is, how did the choices that you made when designing your research method impact your research process?
Um, I guess one choice that I made was um, like which mathematical models I used, and since like I used the near field far field model and the well mixture model, and that kind of impacted um, which types of case studies that I eventually chose. Since like depending on the model, the tool actually requires extremely different inputs depending on which of the models we use, since they're designed for different types of situations. So yeah, so as a result of my choice to go with those two baseline models, that influenced the types of case studies that I look for while reading through research papers, studies previously done on mathematical modeling, and checklists to find the eventual case studies that I would use for my own research project.
That makes sense. Wonderful. Well, that finishes the formal part of your presentation with oral defense.